times the derivative first. It was 1. There's our numerator now. Right? Negative 1 goes to 0. Over 1. Where? Okay. So now we just have to figure out what's happening as x goes to 0. So, last two products, I hate you. So x going towards 0 gives you what? In cosecant squared. What does that give you?
Why don't you use the product rule for x cot x?
You say product rule, you mean take the derivative of x cot x?
Yeah, like the derivative rule, like the product derivative rule.
I did. That is what this is.
Oh, okay.
Isn't the derivative of cotan negative cosecant squared?
I don't know. I didn't see it on the board, so I just.
How did you get there?
How do we get where? To this?
Yeah.
We decided that this x cot x is heading towards 1. Heading towards 1. What's 1 minus 1? 0. So this is a 0 to 0 case.
Wait a minute, but if x is going to 0 on the top, like the first x?
Oh dear. You should have had your eyes on the board earlier.
I was listening, but...
What's cot x heading towards? Infinity. So this is a 0 times infinity case. I cannot claim this is heading towards 0. If it was 0 times a 1 case, or 0 times an 8 case, or 0 times anything finite, I would agree with you, it's still heading towards 0, but it's 0 infinity case. So I don't know. So we just ran the limit on this to see what's happening. It's heading towards 1. 1 minus 1 is 0. So now the top's heading towards 0. The bottom's heading towards 0 because it is x itself. So it's 0, 0 case. So we apply L'Hopital's rule, which is take the derivative of top, derivative of bottom. Derivative of bottom is 1. Derivative of top, this goes to 0 in the derivative. We're left with the derivative of this, which is the product rule, which is first times derivative of second. Derivative of second is negative cosecant squared minus, oh, that's what you're talking about. Right. That's what you're talking about. Thank you. Plus second times derivative of first. Derivative of first is a 1, which I did not write. So now, again, as x goes to 0 in here, what's happening? What is cosecant of 0?
1 over sine, so.
Son of a gun. What is it? 1 over?
Infinity?
Yeah, it's 1 over 0 is infinity. So what do we have now?
So,
You have embedded in here another 0 times infinity case. I guess it's really negative infinity, whatever. Now what's this case over here? What's, as x goes to 0, what's caught?
1 over 10, so 0, so it's an infinity case?
That's correct. So the whole thing now revolves around, this is what you need to pay attention to. The whole thing revolves around this little guy right here. This is irrelevant. This infinity is irrelevant. Right now. Okay? The whole thing is revolving around this indeterminate product that this is changed into. 0 times negative infinity. If this heads towards 0, then the infinity will win. Infinity is the answer, right? If this heads towards an infinity, then there's something to say about this. Right? This is coming to play again. So we gotta see what this is doing. Let's see what this is doing.
So you're going to pull it back out and use the product?
That's right. Lim negative x cosecant squared x, as x goes to 0 from the right, is an indeterminate product of 0 times infinity. Negative on the outside. Okay? So you'll change it to what? X over sine squared. This one's a booger, isn't it? So you'll change it to lim of negative x over sine squared. Now you have an indeterminate quotient. This really illustrates how to use these techniques together, by the way. Okay. So it's now a 0 to 0 case. So take the derivative, and according to L'Hopital's rule, it's going to be negative 1 over 2 sine cosine. Oh. So now what's the answer? Lim as x goes to 0 from the right is
Negative infinity?
negative infinity.
So you have a negative infinity plus a positive infinity?
Which means what? We are now back at what? We're back at another indeterminate difference, written in a different way. So now that we know that this piece here is heading towards negative infinity, it's now negative infinity plus positive infinity. That is an indeterminate difference. So we need to rewrite this as an indeterminate quotient. So what this really means is, the way we constructed this to begin with was not the best way possible. Right? When we wrote this as this, it's leading us down this path to another indeterminate difference. So the most obvious way to construct a quotient here was perhaps not the best way for this problem. It's hard to know that in advance. All right? Nevertheless, let's write this stage.
You
So-
write it in a different color.
What color? You want red?
Yeah. Or, I don't know, something.
Red for danger.
I might, like, use it with all the other writing.
All right? So we now have lim as x goes to 0 from the right of this same expression, negative x cosecant squared x plus cot x. Well, we know this is negative infinity plus infinity case, so we need to write this as an indeterminate quotient. So this time we will use the fact that cosecant is a 1 over sine and cot is a cosine on sine. We're going to change from that form.
Wait, where we get that equation from?
This same thing is right here, exact same thing.
Okay.
I took away the 1 because it's superfluous, and I moved the negative to the outside of this. Other than that, it's the exact same thing.
Okay.
We have to analyze this thing now. Negative infinity plus infinity, which is the same as infinity minus infinity. It's all the same thing, right? So only we're adding two different signs. Okay. So we'll write this as lim negative x on sine squared plus cos x on sine x. Are we okay with that? Big deal?
Why is your cos next up in the top?
Because cotan is cos on sine.
Oh.
This is cotan, there's not a cosecant.
Would that,
So the red is helping.
Yeah.
All right, if we combine this into one denominator, right, then we need to give a sine x over sine x to this piece, so they both have sine squares at the bottom. So we then read as one rational expression, x heads towards 0 from the right, of negative x plus sine cos over sine squared. Yeah? That's what we have now. Is it a 0, 0 case? Yes. This says negative 0 plus 0 times 1. As x goes to 0, so that is 0 plus 0. And the bottom is 0 squared, which is 0. So it's back to an indeterminate quotient of 0 over 0. But hopefully this time will lead us to a conclusion instead of another indeterminate difference. If it does, we're going to stop doing this problem because I don't like it anymore. What do you want to say, Cornell?
What about the sine squared x at the bottom?
What
Because
about
the last one said sine squared x plus
I
sine
just said
x.
sine squared x.
Times sine x.
And then
Sine x. So I gave this a sine, this a sine. So they have the same denominator.
Oh,
You sure?
yeah.
Okay. So now we can apply L'Hopital's rule and take the limit. Sorry, take the limit. Take the limit of the derivatives. Take the derivative of the top and bottom. So the derivative of the top is negative 1 plus the derivative of sine cos. So first times the derivative of the second. Lou, make sure I get the signs right. Plus the second times the derivative of the first. Cos x, I didn't even fit in there. Cos x, there we go. Derivative of the bottom.
Or is that too close to cos x?
It's cos x, which is the same as cos squared. So cos squared x. 2 sine cos on the bottom. X. That's the derivative top and bottom separately. X heading towards 0 from the right.